Hello everyone, I'm Alfian and today we are going to solve the LeetCode challenge or the challenge number 226 called the Invert binary tree. And for this challenge it is on difficulty easy and we are using the TypeScript language. If you want to use something else other than TypeScript, then go ahead, I encourage you to do so. And the description says, given the root of a binary tree, invert the tree and then return its root. And we have a definition of the class called the tree node, which is as the value of L, which is the number, the type of number, and the left node in the form of another tree node, either tree node or null, and the right node it is possible that is chained with another tree node or null. The constructor of the class tree node, we have the constructor of the that will have three properties, which is the val of the value. It is possible to be undefined. If it's undefined, then return 0 as the value, and or the value itself assigned as the value or data. And the left node, it is possible to be undefined. If it's undefined, then it is going to be null, and if it's there, then it is going to be assigned with the another node. The same thing goes to the right property. And we have the function called the invert tree that takes one parameter, which is the name of the root, and it is possible that it's either another tree node or a null, and the possible output from this function is either tree node or null. And we have the input, which is visualized as the array, but in the real case it is in the form of a tree node, which is 4. We have the left property of 2 and the right property of 7, and we have sub property from the 2 node, which is 1 as the left property and 3 as the right property. The same thing goes to the rest of the sub nodes or the sub branches. And the output, it is mirrored, that the 9 is placed on the first and the 6 is placed on the second instead of the fourth and third of the placement, but they are also still following the 7 parent node, which is the root, and the 2 is also the root from the 3 and 1. And as you can see, 3 and 1 is swapped between one another, and also the 2 and 7 is finally swapped between one and another. And 4, it is still right here. It's because it's the root of all of the nodes. And we have the example number 2. Since 2, it is the root of the nodes of the left and right property, and we have only 1 and 3 swapping places. And for the example number 3, we have root of null, and the output is also null. And so without further ado, let's solve this out. To example 3, we have an edge case to check if it's null. If the root is equals to null, then of course we are going to return null. Why? It's because the root parameter right here, it is possible that it can be null, and also the output is also following the null from the output, just like for the example 3. And since root is strictly equals to null, then we can simplify this by using the root with the exclamation mark before the parameter right here. So it is equivalent to use the exclamation mark root. It is as the same as using the root is strictly equals to null. Then of course we are returning null. And the next one, we can return root as our root answer that leads the branches of 1 and 3. And to solve this out, we need some kind of swapper that takes the left is in the root dot left property. We can assign the root dot right, and for the next one we can assign root dot right swap with the left is in the root dot left. But that way it will only process on the depth of 1 or just one depth of branch instead of the sub branches after the main branch of the 2 and 7. So the rest of the branches, which is 1 and 3, will not be processed right away. So this approach is kind of invalid and it is incomplete. So to solve this out, we need some kind of recursion function. What is recursion? A recursion is a function that after we call the function inside, we call the code inside this function, which is calling the invert3 function, and inside the invert3 function we can call the another instance of the invert3 function inside the function itself called the invert3. And that way we are using the recursion approach. To visualize this, I'm using the we have the 4 as the root node, and we have root.left, which is 2, and we have root.right, which is 7. If we only just reassign the 2 and 7 swapping place, then 2 and 7, then the 1 and 3 will follow to the right side, and 6 to 9 will follow to the left side. But 1 and 3 will not swap places, and also 6 and 9 will not swap places because it is on another depth and it is not being accessed. To access this, we can use the invert3 or using the recursive, calling the function itself. We can check on the node called 2, and we can call the recursive function to swap the 1 and 3 with one another, just like this one, and 6 to 9 just like this one. And you don't have to worry about accessing 3 as our sub 3 to check if 3 has the branches of with the left property and also the right property. Since 3 doesn't have the left and right property, then it will return null because it is already defined from the edge case check right here. And then after that we can swap places between the left and right. We are moving right here. So let's go back to our code by creating a recursive call using the constant left branch, and we call the function itself is in the invert3 that takes the property of the root.left, and the same thing goes to the constant right branch, and you guess it using the invert3 again that takes the parameter of the root.right. And after this left and right branch assignment, we can simply use the root left using this right branch as already described from the operation between the node 2 and node 7 that carries the 3 and 1 as the sub nodes, and 2 and 7 will be swapping places and we will get the desired position. So let's assign our left branch to our root.right and also the right branch onto the root.left using the left branch. So you don't have to worry about the next invert3 of the left branch if it is null or not. If it is null, then it will be already handled by the if root is null, then of course we are only returning null and the left branch will be returning null. And if it's null, then the root.left will be root.right. If it's operating on the left branch, then the root.right will be null and the root.left will be filled with the right branch from the recursion call. So let's run this code to see if it works. And we have accepted solution. So let's run the code using the submitting, Control Enter. Okay, so that's about it. I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge or by using stack or something else, tell us what you think in the comment section. Thank you for watching the video. I hope you have a great day and I will see you in the next video. Goodbye.